Hello guys, today we're gonna make a bootloader in assembly. So let's begin. First of all, I have to start my WSL so I can have Debian because we're going to work on Linux now and not Windows. Actually, Windows won't be good for that. Then I create a video bootloader one, just a directory. Then let's begin with let's make one and then make a assembly file. I can start at assembly.asm. So today's goal for our video is to display hello world on the screen in BIOS. So it's easy to do. First of all, we need to learn how what is assembly actually. Assembly is a low level programming language that you can use. It's not like other conventional languages like C, C++, or even Python. It's yeah, the Python syntax matches with assembly, but no, it's not like them. It is very different. It's just binary, but in English. So it's human readable. Not quite human readable, but yeah, you can read it better than reading 0 and 1. So first of all, we need to know what is a video mode. So BIOS uses something called a video mode. What does this show is like we can have different resolutions in our computers. Same BIOS also has them. You, every video mode displays what you have to display, a text or you display graphics, what's the resolution of the display, how many characters you can display, and what's the colors and all these things. So we are going to use 03H or 3 in hexadecimal. This is what we're going to use today. So let's begin. It has 80 into 25 carats, means 80 that are horizontal and 25 that are vertical characters. So first of all, before even starting this video, I had to actually mention that we have to install some packages so that we can compile and run it. So for compiling NASM, the net wide assembler that is made by Intel, it is used for it is an assembler that you can do use to compile or I mean assemble from a .asm file to a file that you want to run. Like we are going to, in this case, use an ISO file because it's what we are going to use because it's a bin file which is packed in an ISO file. So if you have NASM, then we need to run it. So we need a virtual machine. You can use VirtualBox, but that's going to be very slow. So I would recommend going with QEMU. Then only the thing which we need. If you are in Arch Linux, then you can actually download the full QEMU system. That is QEMU-all, I guess, or QEMU-system-all. But we install this. I already have this installed, so we can continue. So I open my assembly. So first of all, we need to do is we need to switch to that video mode. So in assembly, we have MOV. This is moving. So we can move registers. Now I need to teach you what are registers. So registers are like memory, but in your CPU. They are very super fast, even faster than your CPU, even faster than your memory. Like that is your RAM. These are very small, and everything works because of these registers. You assign different data in these registers, and these registers tell the CPU what to do. So let's begin. So we are going to use these registers. These are AH, AL, and let's continue. So first, okay, also a semicolon means comment. So let's start. First of all, we need to move AH to 0, that is for switching to video mode. So for switching to video mode. Then we have move AL. This is what the video mode, that is 03H or simply 03. You can say this is the video mode for video mode for 0. It is for 80 x 25 carats color mode. Okay, so we have done this much. Now we need to do is int 0x10. This is int does not mean integer. Here int means interrupt. So we are interrupting the CPU and telling the CPU to actually run this, to actually uh, have this run. 0x10 is a hexadecimal value which actually says the CPU to run this. So it's, you can check it out on Google. So here we have the CPU interrupt. Here we go. Wait, yeah. Now we need to learn how to compile them. So compile this, you can go into NASM, then the name of the file, dash O for output, then main.iso for ISO file, and see it compiles. Now to run it, type quemu dash system dash x86 underscore 64, that is then main.iso, and here we go. See, first of all, we are getting this error because it did not run. See, nothing, no bootloader found. See, no bootable device. Now this error comes because this, what's the size of our ISO file? It's less than 512 bytes. So we need to set the size of a file to be 100. So to be 512 bytes, because bootloader is defined by its size, that is 512 bytes. Whenever whenever we start BIOS or we start a computer, first BIOS starts. After starting BIOS, it goes through all the memory and means I mean the hard disk, and it checks for the 512 byte file. The one it finds, it tries to run it because that's the bootloader. Okay. So that's the end of the file. You have to write times 510 minus dollar minus dollar dollar db0 db0x55 0x double a. Wait, 0x double a. So you don't need to understand this. This just need to tell you that we are filling the rest of the file with 0 bytes, with 0 zeros, to complete 512 bytes. I will explain this, how this happens in the later videos. So let's compile it again. And here we go, and see this. Now see, it guess has not initialized the display yet. Okay, but it works, and see, boom, it works. That was a bug in WSL, but no issue. See, now we have a booting system with nothing to show. Okay, so now we need to print something. So to print something, we need to send a character. We can send a character using, first switching to teletype mode. This command switches to teletype mode. Switches to teletype mode. Then move AL. AL is what you have to put in. I can put like H. Then int 0x10. This is again to run it. So what we do is to print and run. Interrupt the CPU. And here we go again. And see this, we got H. Congrats if it runs. Now let's continue printing hello world. So to print hello world, we have to type it again and again like this. Move A0x0E. No, we don't need to type it again because we are already in teletype mode. Just write E in 0x10, write L, then write again L. So if you're writing L, it's already in that register. So you can just type it 2 times and type O and 10, and it is done. Now let's compile it. Let's run it. And that's hello. There we get hello. Congrats. Thank you guys. Next time I will teach you how to write it using a string and not using a char.